Hi everyone. I'm going to go through the unit review with you. So after you have completed it on your own, you're going to watch this screencast and hopefully correct your answers. So working on the problems in this unit have helped you understand area and perimeter. You should have learned efficient strategies for calculating the area and perimeter of figures like triangles, rectangles, and parallelograms. You should have been able to investigate the relationship between the area and perimeter of polygons, and to investigate the relationship between surface area and volume of triangles, rectangles, and parallelograms. So in the first problem, it's just asking you to find the area of this irregular figure. So what I'm going to do is I'm going to decompose it into shapes that I'm familiar with and that I can find the area of easily. So you may not have cut it up the way that I'm going to, but we should all get to the same answer in the end. So immediately I see a triangle on the top. I'm going to cut it into a rectangle in the center, and then I can see another triangle on the side. I'm going to real quick jot down the formulas for area of a triangle. So area of a triangle, it's going to be base times height divided by 2. And over here for my rectangle, I'm just going to do base times height. Alrighty, so I'm going to take it a piece at a time. The base on this triangle is 1, 2, 3, 4, 5 units. And the height is 1, 2, 3 units. 5 times 3 is 15. And 15 divided by 2 is 7.5. So I know that this triangle right here, the whole area is 7.5. Keeping with that base times height idea, I'm going to use this side as my base. So even if it helps, you can turn it upside down because it doesn't matter what side of the triangle you use for your base. This base is 2. This height is 3. A 3 by 2 gives me an area of 6. I'm going to cut it in half so that that area is 3. I can tell that this rectangle right here is 3 by 1, 2, 3, 4, 5, 6, 7. So that area in that rectangle is 21, 3 by 7. And this is a 3 by 3, which gives me an area of 9. Cut it in half for an area of 4.5. So I have all my pieces figured out. To find the total area of the hexagon, I'm just going to add them together. I'm going to put the 4.5 and the 7.5 together just so I can combine those halves into one whole. So those pieces add up to 12. 12 plus 3 is 15. And then I'm going to add 15 plus 21 for that final piece. So the total area of all my figures is 36 square centimeters. The second question asks 2 different strategies for calculating the area. My 2 strategies would be to decompose and find area of pieces. My second strategy, even though not very efficient, would be to count squares. So 1 I could decompose, 2 I could count squares. Number 2. Amy has a gift box for her mother that she needs to wrap. She designs a gift box in the shape of a rectangular prism. The dimensions of the prism are 6 by 6 by 7. What is the volume of the gift box? Okay, so we know the formula for volume. Volume is length times width times height. Or you could have found the area of the bottom. Area of the bottom layer. And then multiplied that by the height. Since there's no picture here for me to kind of get a good visual of the bottom layer, I'm just going to do 6 times 6 times 7. Length times width times height. 6 times 6 equals 36, and 36 times 7, give me a second, 30 times 7 is 210, 6 times 7 is 42, so I'm going to say that the volume of that gift box is 252 inches cubed. So cubic inches. 252 would fit into that box to fill the volume. Part 2 asks about the surface area. And this is all the same box. Here it is, what it would look like in real life. This is what it would look like semi-unfolded into a net, if that helps you think about it. Or I like this version of it right here where we can see the 3 sides. We can see the top, we can see the front, and we can see one side. When we're talking about surface area, I'm talking about the area of all the faces. So even though in this version of it, I can't see all the faces, I can only see the 3 in this picture, I know that the opposite sides of these boxes are going to be equal. So if I know the area of the 3 that I can see, I can double it to find the 3 that I can't see. So looking at the front face is 7 by 6. So I know that that area is 42. Looking at the side face, I can see that that rectangle is also 7 by 6. I can tell that this is 7 because the opposite side of the rectangle is 7. So the area is also 42. I can find the area of the top. I know that the top is 6 by 6. Also by looking at the opposite sides of my rectangle, I can get those side lengths. 6 times 6 is 36. So I have the area of 3 faces. So I know that if I double it, I can find the area of the other 3 faces. So I'm going to add these up. 42 plus 42 is 84, and 84 plus 36, 8, 9, 10, 11, 12, is 120. So that's 120 squares would cover the faces that I can see. Now I need to double that for the 3 faces that I can't see. So I know that my surface area is 240 square units, or square inches. Here we go. We now need the surface area of the triangular prism below. So they have it shown to us in 2 different ways. They have the triangular prism folded up so that there's a triangle on the front and the back, and the sides are made up of rectangles. And they have it laid out in a net. Since I'm looking at the surface area, again I want the area of all the faces that we can see. In this case, this prism has 5 faces. I want to find the area of all 5. So I'm going to start a piece at a time using my rectangle and triangle formulas again to find the area of my pieces. So again, my triangle is base times height divided by 2, and my rectangle is length times width, or base times height, whatever you want to call it, for area. All right, I'm going to start this a piece at a time. I'm going to start with my triangles. The base of my triangle is 3. The height of my triangle is 4. 3 times 4 is 12. And half of 12 is 6. If that's 6, I know that this is also 6 because the front and the back of my shape are the same. I'm going to look at the base next. Since this side is 6, I know that this side of the rectangle is also 6. A 3 by 6 rectangle has an area of 18. I'm just multiplying the length and the width. Now I've got these two rectangles on the side. I know that the side length is 6, but I'm not sure about this length right here. So I know that when it's folded up, the diagonal edge of my prism, this side and this side are the same. So I know that this side is 5 centimeters also, because when we fold it up, it's going to rest along this edge of the triangle. So I've got a 5 by 6 rectangle here with an area of 30, and this side is also, well, let's check this side. This side has a side length of 6, and this side is going to fold up against the back of my triangle. So this is a 6 by 4. This is going to have an area of 24. So this piece right here is a little bit bigger than this piece. So we've got all of our areas, and we can add them up. So I'm going to do the 6 and the 6 to make 12. I'm going to add 12 and 24. So I know I did that one, I know I did that one and that one. 6, so that makes 36 altogether. I'm going to add 36 and 18 next to make 54. I'm going to add my 30 in last to give me a total surface area of 84 square centimeters. All right, next question. Give a formula for finding the area of each figure. All right, a rectangle. We should know these by heart. Rectangle is, the area of a rectangle is length times width. The area of a triangle, length times width divided by 2, or we can call it base times height. Let's call it base times height. That's what we've been calling it so far. Parallelogram. Parallelogram is just the same thing as a rectangle. It's just tilted over a little bit. You still use the base times height formula or length times width formula for parallelograms. And there you go. Every single time. It always works. Number 6 says, explain the role that a square or rectangle plays in developing the area of a triangle and the area of a parallelogram. I'm going to pause right here. You're going to have to check out this answer in Unit Review Part 2 because I'm running out of time.